This one, the amplitude of the graph shown above is what? So amplitude from a graph. Amplitude from a graph, we should be using that same formula over and over and over. Amplitude equals the absolute value of the max minus the min divided by 2, which is 6 over 2, which is 3. You should have 3. Then flip over. Okay, here we have the partial graphs of two different functions, y equals f of x and g of x are shown below. Now it says the domain for both graphs is XER. Is that true? Goes on for life? Yes, that is a true statement. Statement 2 says the period is the same for both graphs. Is the period the same how long it takes to repeat itself? Let's find the first one. I start here. I go past the max, past the min, back up to that height, and it's 2 pi, right? The blue graph is 2 pi period. What about the red graph? We start here, past the max, past the min, back up to that height, and it's at pi. So this one has a period of 2 pi. This one has a period of pi. Are they the same? It's not a trick question. Are they the same? No. The amplitude is the same. Your amplitude for this graph equals the absolute value of the max, which is 3, minus the min, which is -1, divided by 2, which is 2, because it'd be 4 divided by 2. And the amplitude of this graph, oh, it's doing it again, equals the absolute value of the max, which is -1, minus the min, which is -5, divided by 2, which is 4, divided by 2, which is 2. So are the amplitudes the same? Is the height differential between these two both 4? The amplitude's half of it, right? So they both have an amplitude of 2. So that's good. Statement 4, we're going to prove it anyways. If I want the midline, I do the max plus min divided by 2, right? So I get 3 plus -1 divided by 2. So it's at y equals 2 divided by 2, which is y equals 1. That's the midline of this one. So that's the line that cuts the graph in half. Is this one also 1? Is the line that cuts the graph in half of this one a 1? No. It's way down here. I don't know why I said it is no, but I did. Okay. The midline for this one, remember midlines are y equals. Y equals max, which is -1, plus min, which is -5, divided by 2, which is -6 divided by 2, which is -3. Remember it's y equals, and remember it's not absolute value signs. So are the midlines the same? No, one's at y equals 1 and one's at y equals -3. Make sure you're paying attention. So the true statements are 1 and 3, which is C. Then we flip over. This one says the following graph of y equals f of x. One change is made to create a new graph y equals g of x. This is described by doubling the amplitude. So I'm doubling the amplitude. I'm making it the distance twice as high, right? So if I want to double the amplitude, my midline is here. I just draw my midline, pretend it's straight, which is at y equals 5, right? So it's how much to get me here? 1, right? It's from 5 to 6. So if I want to double it, I'm going to have to go to, where? 7. And then this one is down to 4. If I want to double it, I need to go down to 3. So you're just doubling that half that distance, right? So we're going from 3 to 7. So this is 3. It's always min to max is y is less than or equal to 7. And it wants the sum. What does sum mean? Add them. So what's 3 plus 7? 10. Okay, the next one says the graph has a minimum value of -4 and k is a point, bless you, on the x-axis. So if I'm going from here, past the max, back down to that height, how much of a period is this? How much of the period is that? If I go past the max, back to that height? Half of it, because I need to go past the min and back up to that height to get the full period, right? Like I'd have to do this. So if it takes me k to get to half of it, how much is it going to take me to get to the whole of it? 2k. So this one says the expression for the period in terms of k is 2k. So this one here says a sinusoidal graph has a maximum of 10 and a minimum of 2. This shouldn't be hard tomorrow. You can look at the formulas, right? You have an open book. You should not be getting these formulas wrong, I hope. So you have a maximum of 10 and a minimum of 2, and they want the amplitude. So the amplitude equals the absolute value of the max minus the min divided by 2, which is 8 over 2, which is 4. The midline is the addition of them without absolute values. So it's going to be 10 plus 2 divided by 2, which is 6. So your amplitude is 4, and your midline is y equals 6. So it's B. So for 7, it says the graph of y equals f of x displays points -4.2830 and 20. The graph displays the points 2 pi and 0. So it wants to know when comparing the graphs of y equals f of x and g of x, it can be stated that they have different periods. Well, do these things repeat themselves longer? Well, let's check. Start at the y, past the min, past the max, back up to that height. Gets me like here, which they say is 2 pi and 0, right? So that's a period of 2 pi, that blue graph. Let's look at the red graph. Past the max, past the min, back up to that height. It's 2 pi. Are the periods different? These graphs have different periods? They both end in 2 pi, right? When I count the repetition. So they don't have different periods. What about amplitudes? Are they both the exact same height vertically? That's a distance of 4, correct? So their amplitude would be 2 and 2, because half the distance is your amplitude. So they have the same amplitude. What about the midline, the line that cuts them in half? They both have a midline at y equals 0, right? And then it says none of the above, so it's B. The great thing about diplomas, none of the above never happens. So here we have the sinusoidal graph of a Ferris wheel. Below shows the relationship between the height above the ground and time. Now, if I wanted an equation, could I not just type in 5 points into my list 1, list 2, and get a sinusoidal regression? Yeah, it can give me an equation. As long as I have 5 points, I can get an equation. So if I wanted to get an equation, my x value, this one would be 0, 0. Then this one would be 20, 20. Then this one would be 40 and 0. Then this one would be 60 and 20. Then I would get to 80 and 0. And as long as I have 5, I can run a regression. Everyone's typing that in, list 1, list 2. Let's try it out. Now, when we're calculating this, what are we going to pick to calculate it? We picked 4 for linear, 5 for quadratic, 6 for cubic, 9 and 0 for exponential and logarithmic. Which one do you think we're going to pick for sinusoidal? I think I hear people whispering it. C, sine reg. So we go stat, calc, and then I arrow up to get to sine, because it's the second one from the bottom of the list, but you can arrow down till you get to it. Hit enter and get it into your y equals.
What if we had an error? Yeah.
Shouldn't be error. 0, 20, 0, 20. I think it's mad because I don't have in between ones. Like I could put these ones too. Go to your list and go 0, 10, 20, 30, 40, 50, 60, 70, 80. And then on the bottom, you would get 0, 10, 20, 10, 0, 10, 20, 10, 0. Try that. Does everyone have it in? Because I didn't give those middle values that it was like, I don't know, this could be straight up, straight down, straight up, straight down, right? Like I didn't give enough of the curve in between, so it kind of fought it. But, so we have that equation that sits in front of us, right? So we have the A, the B, the C, the D. We can fill it in. I just wanted to show you that any graph you can run a regression on if you need to get an equation out of it, right? Are regressions perfect? No, not unless the data perfectly fits it. So we're going to talk about this as opposed to a wheel, okay? This is a person getting on at the very bottom at 0. Oh, I ran out of space. Pretend it's a perfect circle. That's not. Here's the center, right, of the circle. Here we're at 0, 0. We agree? 0 seconds, 0 meters. What happens when I get to here? I was at 10 seconds and 10 meters, right? And what about up here? 20 seconds, 20 meters. When I get back down here, where am I at? 30 seconds, 30 meters. And then here I'm at 40 seconds, 40 meters. And I could just keep going around and around and around and around and around, right? So, on a Ferris wheel, what are certain things? Well, let's talk about it. So, I know that from here to here is what? What is this on a graph? From here to here, here to here. What is it called? The amplitude, correct? So on this wheel, that's from here to here and here to here. Oh gosh, here to here. That's the amplitude, right? What is that on a wheel though? The radius. So your amplitude is actually equal to the radius. Radius, amplitude are interchangeable. Something to note. Radius, amplitude, interchangeable. Okay? It's hardcore. That person's not going to be able to talk tomorrow. Okay, so when the ride begins, the height above the ground is what? How far are we above the ground? How far does this start off the ground? 0. The time taken to complete one full revolution. Now this is the thing here. Complete a revolution. That is a fancy way of saying period. Because period is how long it takes to repeat itself for one full revolution, right? So how long did this one take till it repeated itself? How many seconds? 40. This whole circle took 40 seconds. So the period of this graph equals 40, but also one revolution is 40. They're interchangeable. So radius is interchangeable with amplitude. One revolution is interchangeable with period. Now it wants the radius. What is the radius of this one? It was 10, right? Because it was just half of the diameter, right? The diameter is 20. So this is 10 and this is 10. So my radius is 10. So then this is 10. What's the max height? 20. In 80 seconds, a rider will reach a maximum height of 15 meters. How many times? So in 80 seconds, let's look. So we go 15 meters falls in here somewhere, right? Like that. It's a little higher, but I'm not erasing it. So we 1, 2, 3, 4 times. The other thing we need to know is the other word. What is the midline interchangeable with on a question like this? Where would the midline be on this graph? How many meters? Pardon? People are saying it. 10? So the midline on this graph would be at 10 meters. Correct? This is where the midline is. What does it correlate to the wheel? Where is that on the wheel? Starts with a C. Ooh, where is that on the wheel? It's crossing right through the where of the wheel? The center. Oh boy. The very middle of the wheel, the very center of the wheel is the midline, right? The midline is what cuts the graph in half. It also cuts the wheel in half. It's the center of the wheel. So midline and center are interchangeable. So I'm going to write these down here. Midline and center are interchangeable. Amplitude and what is interchangeable? Period is interchangeable with what on a Ferris wheel or a wheel in general? One complete revolution. I don't know. There's between that and, yeah, I don't know. All right. Here we have the graph below shows a maximum 0.53 and its closest minimum is 8, -3. What's the period? You guys try this one out. Press that. The domain is from -pi to pi. The range is from -1 to 7. Y-intercept of 3. A period of 2 pi. Observe Tony's graph below. Analyze Tony's graph. Explain which parameters were sketched correctly and which parameters were sketched incorrectly. Well, let's go back here. The domain is from -pi to pi. Is that true? The domain of this one's from -3 pi over 2 to 3 pi over 2, so that's not right. The range is from -1 to 7. -1 to 7. Is that right? Yes, that one's good. The y-intercept is 3. Yep. The period is 2 pi. Well, let's check it out. Go from here. At the y-intercept, past a max, past a min, back up to that height is here, which is pi. The period is 2. Nope. Right? So I just want you to analyze it. So you'd have to explain. If it says analyze, you have to explain. The period they say that Tony says is 2 pi, but it's actually pi. And the y-intercept is at 3, which is accurate. Okay. This one. When you breathe, the air entering your lungs is a positive velocity and the air exiting and the air exiting your lungs has a negative velocity. The relationship between velocity and liters of air per second, liters per second, and time in seconds for an adult at rest can be modeled by the graph shown below. What is the equation of the midline? What is it? It's y equals 0, and it's when it's before, it's the transition between breathing and inhaling and exhaling, right? It's that transition spot. What is the amplitude? If the midline is here, amplitude from the midline to the max, right? So this is 0.5, this would be 0.6, 0.7, 0.8. Could I use the formula off my formula sheet? Yes, it'll still get you 0.8. What is the period of the function? What does it represent in this situation? So what's the period? So I'm going to start here. I'm going to go past the max, past the min, then back up to that mirror height, which is here, which is at 11. 11 what? 11 what? What's my x-axis in? My x-axis is time. What's the time in? Seconds. What does this represent? An inhale and exhale. So what does that represent? One breath. Okay, this one says, consider the following 4 sinusoidal functions. They want the equation with an amplitude of 3. Which one has amplitude 3? Number 2, because your amplitude is the absolute value of A. What if this was a negative 3? What would its amplitude be? 3. It doesn't change, right? Your amplitude is the absolute value of A. So it's equation 2. Then I want one with the period of pi. Remember, off of an equation, it's the only it's the only 2 formulas on your formula sheet. The equation of the sine function and period. How to find the period from a sine function, like it shows it to you, right? So the period of this one equals 2 pi divided by b. B is always what falls between sine and x. So this one is pi, which happens to be the right answer. This one, the period, equals 2 pi divided by b. B happens to be 5, so this is 2 pi over 5. The period of this one equals 2 pi divided by 1/5. When you divide by 1/5, it's multiplying by 5, so you get 10 pi. And then this one equals 2 pi over 3. So the equation with pi as your period is equation number 1. Which one has a midline of 5? How do I find the midline? The d value. This one is plus 5, this one is minus 5. So which one is actually correct? 3. Now an aside, how do I get a maximum from an equation? You turn German. What do we make it? Ah. So you do d plus your amplitude. And then this one is d minus your amplitude, not your a value, your amplitude, right? Because if your a is negative, you still use amplitude. So I can quickly get maxes and mins from every single equation if I remember DA. So I should have that. This one, y equals cos 2x minus 1. Does the cos change anything for us? No. The single adjustment which would make this graph have no x-intercepts would be moving the midline down. If I move the equation of the midline down, if it's here, let's say, and I take it and I drop it, it'll take this max and it'll drop it below. So it's C. Flipping over. Does it matter that it has a cos in it? No, it's still a sinusoidal function. So the graph has a phase shift. Remember I told you all you have to do is look at the C value. If there is a C value, the graph has a phase shift. So that's true. If there isn't a C value, it does not have a phase shift. That's all you need to know. You don't need to know anything about that other than if it exists, it's a phase shift, which means moves it right or left. The period is 2 pi over 3. Well, let's check it out. The period equals 2 pi over b. And my b is what falls pretty close next. So 2 pi over 3. So that's true. Is the amplitude 3? What's the amplitude? 7. It's just my a value, the absolute value of my a value. What's my midline? -1. So Benito correctly identified the two true statements, which are 1 and 2. Okay. I give you a graph. It's between 1 and 7. It has a period of 180 degrees. Should say a period of pi. We don't use degrees in 30-2. So I'm going to go to the next page and I'm going to go min of 1, max of 7, period of pi. So it wants me to get A. How do I get A? A is based off the what? Amplitude, right? Amplitude in A. Amplitude in A, right? So how do I get the amplitude? Well, I have a max and a min. It's easy. Amplitude equals the absolute value of the max minus the min divided by 2, which is 6 divided by 2, which is 3. So currently I have y equals 3 sine. How do I get b? They gave me the period. I have a formula, correct? My formula for the period is period equals 2 pi over b. Remember b is the period, not the period? Or we start with the b. I can swap these. So if I need b, I can put the period on the bottom. If I need the period, I can leave the b on the bottom, right? I can swap them depending on what I need. If I need b, I bring the b up, the period down, I get b equals 2 pi over period. What is the period? What did I give you the period to be? Pi. So I'm going to go 2 pi over period. So 2 pi over pi. The pi's cancel. What's my b value? 2. So now I get a 2 in here. 2x. If there was a c value like x plus pi, then I'd have to go x plus pi. But there isn't one, so I put x. And now I need the d value. What's the d value just the same as? What is your d value? The midline. And how do I find the midline? I do max 7 plus min 1, y equals, sorry, 7 plus 1 divided by 2. So it's going to be y equals 4, a plus 4, correct? You don't absolute value midline. So then I'm going to get a plus 4 back here. How do I get my A, my B, and my D? I never have to find my C. It would have to be given to me. Okay. This one here says, which point could be used with the maximum to determine half of the period? So here's the maximum. What point could I use with it to get half the period? D. Because a max and all the way to the min is half of the period, right? Or a min to a max is half the period. So it's D. (17) The height of a pendulum H in inches above a tabletop T seconds after the pendulum is released can be modeled by this function. Everyone type that into their calculators. Then I'm going to remind you how to make your window. So you're just typing that in. Remember, we can get maxes and mins from equations, right? This is pi t, so you go pi x. So our max, how do we get max and min from an equation? We turn German. What do? Da. We do d, 3.5, plus my amplitude. What if this was a negative 1.5? I would still use positive 1.5. So I go 3.5 plus 1.5, which is 5. This baby's maxing out at 5. Then I have 3.5 minus 1.5, and it's minning out at 2. So this is the pendulum swinging. H is in inches above a tabletop, t seconds after the pendulum is released. So it's swinging from 2 to 5 to 2 to 5 to 2 to 5 to 2 to 5 to 2 to 5, right? That's all it's doing. So I'm going to go to my window, and I'm going to make my y minimum be below 2. So I'm going to make my y min be 0, let's say. Because these are your y mins and maxes. And then I'm going to make my y max be 7, let's say. It has to be just above 5, right? I don't really care about my scale all that much. Now I have to figure out how the heck did I figure out my x's? Well, it's based off the period, right? And how do I get a period of an equation? Use the formula off my formula sheet. So period equals 2 pi over b. What's my b on this equation? Pi. So it's 2 what? 2 seconds. This baby's repeating itself every 2 seconds, correct? Pendulum. Like it makes sense. 2 seconds doesn't take very long for a pendulum to swing. So what's my x min going to be? Time. What can my time x min be? 0. Can't have negative time. It swings the pendulum every 2 seconds. So if you put 2, you're seeing 1 period of the graph. I would put 6. Then you can see 3 pendulum swings, right? Then you can answer any question they ask. They could say, what's the height at 1 second? What's the height at 3 seconds? And you go second trace value 1 and 3, right? Or it could ask you, what time does it reach 3 inches? Well, then you put 3 in your y2 and find out where they intersect, right? But this one says, the height of the pendulum at the moment of release. Remember, we've talked about moment of release. What is that just the same as? Time equals, someone said it, 0. T is just x. So I go second trace value, 0, enter. Try it out. Second trace value, 0, enter. To the nearest inch, what do we get? What's the height at 0? 5? Because it's starting at its maximum, this particular pendulum. Okay. This one wants the period to the nearest tenth. Oh, off of an equation. Should be an easy question. Period off of an equation. Go to the formula sheet. Use my formula, right? That's it. So the period equals 2 pi divided by b. What's my b? What's my b? 0.3. Doesn't matter that's a coast. So it wants it to be written in a decimal. So you put in the pi. So I go 2 pi divided by 0.3. And it's going to equal 20.9. And then it wants the values of k, m, n respectively. So in that order. 209. I give you another equation. What's the first thing you want to do? Type it in and get a freaking window that works. And we can get windows that work by finding the max and the min for our y's and the period, right? So my max is d plus amplitude. So 11 plus 9. Even if this was a negative 9, I would use 9. So this one has a 20 max and a min at 11 minus 9, which is 2. So the height of the rider above the ground on the Ferris wheel can be modeled by this sinusoidal function, where h is the height of the rider above the ground in meters, and t is the time in minutes after the ride starts. So I know that I'm going to make my y min be like 0 and my y max be like 22, right? Because I found these are all, when I do this, this is my y values. How do I figure out what to make my x? Period. Make sure your books aren't away. I know Tyson has to sleep now. So period equals 2 pi. What's the b? 1.05. And we put the whole thing in, the 2, the pi, and the 1.05. 2 times pi divided by 1.05. 5.9839, blah, 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 blah. So that's how long it takes to repeat itself in minutes. So one full revolution is almost 6 minutes, right? So I'm going to make my time start at 0, and then I might make it go to 12, something like double the period. So my x min would be 0, my x max would be 12. This one wants the minimum height. Do I have to do any of what we just did? No, the minimum height would be 2, right? We could get that quickly. 2 meters. But what if I ask you for at 3 minutes what it would be? Well, then you do second trace value 3, right? If I wanted what time did it reach, I can pick anything between 2 and 20. What time did the rider reach 10 meters in the first revolution, right? So then you give me the 2 times. So we can do all of that. The hardest part of this question is to get it to show up on your graph, literally. So if you do the max, the min, and the period, you will find these really easy because you can get them to show up. Other than that, people are willy-nilly just guessing values. That's scary to get your graph to try and show up. This one here, an electric toy car is traveling around a circular track at a constant speed. If they do pendulums or they do anything in a circular motion, they can make it fit a sinusoidal equation. Okay? A ruler is positioned beside the track. So it reaches a max of 70 and a min of 10, it looks like. The position of the car measured in centimeters with a ruler can be modeled by this sinusoidal function where p is the position of the car in centimeters and t is time in seconds. The equation of the midline, what is it? They gave us an equation. How nice are they? What's the equation of the midline of this one? 40. It's just the d value. And the time that it takes the car to travel twice. One revolution is the same as saying what? The period. So I want 2 times the period. That's it. How do I get a period from an equation? Formula sheet, right? So the period equals 2 pi divided by pi over 4. Should be 8. B. Yep. Sorry? Oh, 16. Oh my gosh. I would have got this wrong. Good call. I took a common error. You'd say, absolutely. Bet you that one's picked more than the other one. Okay, we're going to skip 21 for a second here. We're going to go to 22. 22, a Ferris wheel at a local carnival has a diameter of 46 feet. That's the same as a radius of what? If it's a diameter of 46, what's the radius? 23. What's the radius another word for? Amplitude of 23. That one's gone. This one's good. And the minimum height above the ground is 5 feet. Let's do some drawing. So we have a Ferris wheel. So this here is 5 feet. And then my amplitude is 23. So that's 5. My radius is 23. Like I can sketch that, right? And then this is that 5. Guys, what is the maximum? How do I figure it out? We're going from here, right? What's the maximum? 5 plus 23 plus 23. So what's 46 plus 5? 51. Because we're counting from the ground, right? Median is just the midline, right? Median value is just the midline without the y equals. How do I get the median? How do I get the middle? Median, midline, what's that a fancy way of saying? Talked about this on a circle. Nope, amplitude is radius. Center. Where does the center of the circle happen at? 5 plus, we're going from the ground, right? 5 plus 23, which is 28. So if you know that radius is amplitude, you know that midline is center, right? Makes the question way easier. You know 1 revolution is period. So it's 1, 4, and 6. There will be sinusoidal regressions on it. You can practice the last few questions if you'd like. Sinusoidal regression, what's the difference between a sinusoidal regression and every other regression we did? The letter C, that's it. Second, like stat, calc, C, that's it. All the steps are the same, everything else is the same, right? Change your window to the right stuff. Nothing is different in sinusoidal regressions other than pressing C. Tomorrow you have an open book.